Okay, welcome everybody. I hope you're feeling fresh after lunch. We're going to talk now about streaming data with Apache Spark. And just to get you warm up with this, I wanted to know how many of you have worked with Spark? All right, with Spark streaming? And with structured streaming? All right, even fewer. All right, thanks. Probably if you're sitting here, you're wondering why there are two streaming APIs on Spark, how they differ, and why the two are still there and how they can be used. I hope in this presentation to give you answers to all those three questions. Give you an overview about what the streaming APIs in Spark are, what are the structured streaming and versus Spark streaming, what are the different key features and where would you want to use each of them. I am going to use a particular way of bringing that message. I'm going to mix up slides with some live code. I'm terrible at live coding, like typing, but I have everything prepared, so I hope it's a smooth experience for all of you. It's a lot of material, and at some points I will go a bit faster. If it's too much, just let me know. I will kind of focus on the areas that are very important and then skip on areas that are just scaffolding for getting the stream process together. I am Gerard Maas. I work for Lightbend. You all know Lightbend here. And I'm also the author of stream processing with Apache Spark. And part of the things I'm telling you here today are coming from my work writing this book. We started with learning Spark streaming, and over time, the new API for Apache Spark came out, and we decided to include them in the same publication, and we have been working on having a comprehensive coverage of it. That road also taught me a number of lessons, so where they shine and where they should not be used, and how do they compare. Today I'll bring you like the too long, didn't read version of that. First, I think Spark does not need an introduction. Those are the topics I would like to treat today. Go through each one of the APIs separately and use some use cases to illustrate how you use them. What is the feeling? What is the developer experience of those APIs? How you get to create streams, how you get to process the data, and what can you do in practical terms with that data to achieve a given goal. Before we go into the details of the APIs, I want to touch on streaming and big data. The two topics are hot in the industry. We talk a lot about fast data, a lot about reactive, and many times big data and streaming, they get like that an understanding of one or the other is like big data is still a amount of data in some reservoir that you call storage, while streaming is something that is flowing through the system, and you only have a view of that stream, a very brief view over a period of time. So you only can act on the data while that stream of data is passing in front of your eyes, so to say. To give you a comparison of how the two approaches compare, we can, for example, compare 100 terabytes versus 5 megabytes. And then we'll start asking, well, okay, what is that? What is big data? And then probably we'll think that 100 terabytes might be big data for some people, and 5 megabytes certainly not. But if we add that dimension of time to that picture, then it becomes clear those 5 megabytes will become 100 terabytes at some point in time. Do you want to wait till you have that 100 terabytes in hand before you act on the data, or do you want to really take a look at each 5 megabyte portion of 10 megabytes or 100 megabytes at any point in time, and then get some actionable insights from the data? 5 megabytes is about the size of a picture on your phone. So there are business cases around there if you are on Snapchat or any of those. You know that they are doing a lot with this small amount of data, but on the large, and over time becomes a challenging problem. I love these two equations. They are from Tyler Akido from Google. He's one of the persons working on Google Data Flow and Apache Beam. And they represent what the relationship is between a stream and your storage of data or your data at rest. As we collect data from a stream, the stream will become a data set. Typical example of this is a database. If you have users in your system, and not 1,000 million or whatever number of users, they didn't come into your system at once. They came one by one, or maybe in small batches, and they were registered and landed into your system. So they really started as a stream of events coming in that became over time a data set. The same thing happens with when you have a data set, you have established a company, you have an enterprise, you have a number of systems that are currently working on batch, and you would like to get them in let's say, the next gear on the stream, and stream processing. What do? Well, you can start looking at the deltas. You can start looking at the change logs on the databases and derive a stream out of those data sets that are already sitting on your data centers. This is to give you like the introduction on where that stream processing comes from. Is about getting actionable insights on the data as the data passes by. There is the other thing I like to introduce is Apache Spark. Probably doesn't need introductions. In a nutshell, it's a distributed processing system. And what it's good at is at taking a job, let's say a function, and applying that function in many executors on the data that are located on those executors. When we talk about Spark, we talk about two things. One is the Spark core engine. The Spark core engine is very good at taking what is called a data set and distributing it, as I said, applying some computations on top of that. And then there are a number of abstractions built on top of it. We have a Spark SQL that is an implementation of a query optimizer, a catalyst processor on top of that core engine. And then we have, let's say, the Spark SQL family with the data sets and data frames APIs, the graph frames, which is computing over graphs, and then structured streaming. Structured streaming is applying those concepts or data sets and data frames to streaming data. On this side, on your right side, we have Spark Streaming. Spark Streaming was the first API doing streaming on top of Apache Spark and exploited that concept of micro batching. You will get data as it goes into the system. You get like a handful of data. You don't see every element individually, but you wait till you have a certain amount of data in hand, and then you pass it to Spark for processing. We will see in detail how that works. Important to see here is that their level of interaction with the core is different, whereas structured streaming actually uses the Spark SQL APIs to talk to Spark. Spark Streaming can talk directly to the Spark core engine. That will be very important as we'll discuss the different features of the two APIs. There are implementations on Scala, Java, Python, and R for general Spark applications. For streaming, it's a little bit different. I would say it's more limited to Scala, Java, and some Python. And if you are doing a stateful computation of streaming, then it's limited to Scala and Java, because the closures you need to provide there, they need to be on a type-safe language. Let's go first into structured streaming. How does it work? And it relates, again, to the initial concept I brought to you about taking a stream and looking at it as a table. What is the difference? The difference is time. But when you start to think about rows of data coming into your system that they have a given schema, then you can also start thinking about queries that you could apply to that data. And how long do you need to wait to make this query possible? If you're doing a simple transformation, let's say you're doing a select of a name and last name and address of a user that is coming in as a stream, you don't need to accumulate lots of data to get that answer out. It's not a query on a database, it's a query on the stream. On the other hand, if you're saying, I would like to have the maximum and minimum of my sensor of the last 10 minutes, then you also don't need to accumulate a day worth of data. You only need the last 10 minutes. Once that 10-minute window is over, you can discard that data and give a result back to the user. So the concept is data comes in as a stream, is conceptually viewed as a table, so the operations you apply on the stream are SQL operations or SQL-inspired operations. We will see that the API is a DSL inspired on the SQL. That gives the system the opportunity to optimize those queries. As I mentioned, there are some queries that will need data retention in the systems in memory, or there are others that really don't, and you can do a linear mapping of the data coming in to the data coming out. At the exit side, so we call that a source, and we call the other side a sink, and there are a number of sinks that we can apply to our computation to write the data to another system. In particular, Kafka is a very popular choice, so you can have like an input and output in a streaming system, but you can also write to files or write to a database using one of the implementations, or let's say the API level implementation for sinks, like for each sink. Okay, let me jump into the first example on how does it look like to use structured streaming. And I'm going to use this as a running use case through this presentation. I have a sensor here. It's an audience sensor, so it's really making some measurements about you folks being here today. And I would like to use that information to analyze how this session goes. So the first thing we're going to do is to have a look at the data. And what can we learn about the data passing through? And for that, I am going to jump into a notebook. A notebook, for those who is not familiar with notebooks, all right? So they are an interactive way of having a session with the system. Jupyter is a popular option. I am using the Spark notebook. It's an open source project. And my choice for the Spark notebook for today is because it's very good at dealing with reactive updates of the data. So it's very good at having that streaming data, for example, and then updating some of the widgets so we can use to visualize the data. So these are auxiliary definitions I required, so I will have Kafka running on my system as well. And the first thing I'm going to do is I'm going to create a stream from Kafka. And it's this what we need. We say, okay, there is a Spark session that is already provided. It gives you access to a cluster if you have a cluster. I'm running locally, so I give access to my local machine. And I'm going to say I read a stream. And I define my stream using some parameters. In this case, it's Kafka. And I need to provide the address of the Bootstrap server, the subscription mode, and the topic I would like to subscribe to. I need something to produce the data. And to produce the data, I'm going to use a microservice I implemented in Akka. And this one is running actually a simulation plus an actual reading of the sensor that we currently have here live. So we see that there are readings coming in. And so those readings are, also the sensor is a sound sensor. You see it's being influenced by the ambient noise right now. And what we're going to do is to process that data in our stream application. Okay. Next to that sensor data, it is also producing some thousands of other sensors that are simulated. So it is to have not just one little stream of data, but to have something significant where we can act upon. The first thing we see is that this is a streaming data frame. So I created that session. From the session, I created my data frame. It's a raw data frame. What it contains, it's printed in the schema. So structured streaming gets its name from the structure way of looking at the data. We say that the data has given a schema, and we can differentiate fields on the data of different types. Once we have the schema, we can then do smart things with the data. We can know, for example, how to encode the data properly and to have it in memory in cheaper ways than having it on the heap. And Spark is doing a lot of this for us. The schema of Kafka is fixed. It's always the same thing. It has a key and a value, and some metadata being the topic, partition, timestamps, and offsets. We are interested in the values that are coming in through the system. So here we don't see any information about my sensor. The information about the sensor is embedded in that value, and we are going to interpret or read that data by providing the schema. So I'm defining my schema here using a case class. And once I have my case class defined, I can extract the schema out of it. So I'm creating a schema object that is known in Spark that is encoding the schema information that are required to parse the data. And in the data processing side, what I'm going to say is that that stream that we originally had, I am only interested in the value. And that value I'm going to read as a string. So the raw type of a value is a byte array, but we're writing strings to it. We read the strings back. And then in that second line there, I'm saying, and now I want to interpret the string as JSON. So that JSON data in that stream is now going to become, let's say, the first class type for that stream. And at the end, we just say, OK, now I want this stream to have this type. I'm using typed streams. So that's the main difference between data sets and data frames, is that data frames are untyped, and you apply transformations to it by calling the fields by their names. And with data sets, you have a typed interface. So we can also apply our functional knowledge to this stream. So we can do map, flap map, filter, and all those known functions that we have learned from our experience in functional programming. All right, so now I have my schema, and it has an ID, a timestamp. It says temperature and humidity because that was one sensor I was using in the past. We're using now our noise level sensor. And the first thing I would like to do is to visualize the data. How is the data looking like? And for that, I have to materialize the data. So the data is now actually not doing anything. I just declare the stream. I need to say what I want to do with the stream to materialize it. Everything, all the operations here are lazy. And up to the point where I say I want to materialize the data, writing it to somewhere. In my case, I'm going to write it to memory, like I declare here. I'm going to visualize that in a query, and I'm going to write it into memory. Then from that memory table, I can query the data again. This is a normal data set in Spark, and it's not streaming, but it's backed by the streaming query that I just launched. All right, and we can see that data count increases over time. So if I run my count consecutively 2 times, we see that data is coming in, it's flowing into the system. And now I want to create you some widgets. I will just jump through this. And this is something to update my visualization. And now we can visualize the data as it comes in. So if I start speaking louder, I'm sorry for that. I'm not screaming at you. I just want to have some different view of the data. Or if we have a different behavior in our environment, we will be capturing that stream information. And now we have a stream of data coming from a sensor. It's live. It's going through the system. And we can start doing some logic. We can start to applying some logic to it. And so we have some live information right now. One of the features that came with structured streaming is the ability to look at the data from the point of view when it was created. In the past, and we will talk a little bit about it with Spark streaming, we were looking at the data the moment it was arriving in the system, from the point of view of the processing system. So if the data was created on your cell phone, let's say you were on your flight and your heartbeating sensor was measuring you on your flight, you would like to know what happened to you during that flight and not have an alarm maybe when you arrived at the airport saying, oh, you have a really high heartbeat right now. No, it's not. It was like 3 hours ago when the flight was taking off and I was scared. I'm afraid of flying. So that capability of looking at the data by using the timestamp embedded in the data is built into structured streaming. And we can exploit that to create views or aggregations of that data. So I'm going to create window aggregations right now on top of the sensor data. And what I want to do is if observe our data at this moment, it's really jagged. It has too much variance. I would like to have a smooth line to better understand, let's say, the noise levels of this environment. So let me go down a little bit. So I'm going to create a sliding window over 30 seconds of data every 10 seconds. And it has a watermark. Watermark concept is also introduced together with all the structured APIs and the support for event time. And it says everything later than 30 seconds will be discarded. I am interested in fresh data right now. I'm interested in the live feed from my sensor. Everything that arrives too late, it will be not used for my aggregation. Oh, I think I skipped one field here. Okay, same thing. We have a schema here. In this case, now we see the window there. We have the window have a start and an end, and we are obtaining the average of the values that are provided by the sensor. Now I'm going to kind of repeat the same process to get that view, to get a view of the data. And the idea is every time the same. I have declaring a stream, and I need to materialize a stream. And a very easy way to materialize a stream is to materialize it on memory. And that's the first thing that we do here. It's not something you would typically use to write applications for production. You're not going to materialize it in memory unless you're writing, for example, microservices that want to have a view on the local state. OK. So this is our data. We need to wait a little bit. Data is not there yet. We need to wait like 30 seconds for that window to complete. And now we have some data in our moving average stream. And we can also have a look at it. Oh, that doesn't look great. Let's execute this again. And no way. This doesn't, it's not looking at the data as it should. But I don't have time to start debugging this right now. I just hope that the data is being written correctly to the backend. OK, so what I'm going to do now, and maybe I need to check it out, is to write the data back to Kafka. I don't see an obvious error here. OK, let's just do once more. 8 entries in total. Ah, voila. It's taking a while. But there, you see, the line is smoothing out. This is the moving average. And of course, I was getting quieter and worried about why this was not working. But now we see that we are back into business. All right, I'm going to stop all these queries. And you see that I'm managing each query independently. That's also another difference between the two APIs. And stopping that query, and I'm going to write now the query back to Kafka. So I'm getting data from Kafka. I'm processing it, creating this moving average stream, and writing it back to Kafka. I need to create a specific schema for Kafka. I need to be compliant with this key value. And then I start a new query. All right? There are some APIs for monitoring progress. And we see that the query is executing correctly. Let's go back to the presentation. Very quick. And have a look at what we just learned. First, the streams are created using the Spark session and the read stream function. That read stream give us access to all the available sources that are out there today. So there are formats for Kafka, format for files. There are formats also for TCP sockets, and what else? And some JSON and Parquet formats also if you are using files. After you choose the format, then you need to specify specific parameters for the source that you are using. Then we have operations. So the operations are the same for data frames than for streaming data frames. And then what you need to use is a single mental model to write applications that are running in batch mode and write applications that are running in streaming mode. The folks from Databricks, they suggest that you start thinking about your applications as batch applications. You have data, you transform the data, and you get some outputs out there. And most of the API allows you to do so. There are a few exceptions, like a count that is not defined on a stream. A stream is, by definition, infinite until it stops. Event time is embedded into the API. It's very handy when you're having a look at, for example, time series data, as it gives you the facility to aggregate over the data and then also declare how long you are going to wait to deal with the late event. So late event handling is already embedded into the programming model. Those are the elements there. And finally, we have the sinks. The sinks are the counterpart of the sources. What we say is, again, declaratively, write the stream, and then we say the format. There are different formats available. We saw memory. There is also output to the console, and I'm using Kafka to write in this example. All right, what are the use cases? Typical use cases for structured streaming, anything that is giving you a stream that has a schema is a prime candidate for applying structured streaming. Things like ETL on the fly, so you have data arriving, you know the scheme of the data. There are fields, for example, orders, order processing, transaction processing. Those are all good candidates. You can apply this to also IoT data, as I'm doing today with the stream aggregations and window functions. Very handy to do time series analytics. And also, there is an API. It's a little bit more advanced, and I'm not touching it today, but we can do arbitrary stateful stream processing. So you can, for example, compute sessions of people that are visiting your online shop, for example, or cars that are driving around in a city. So when it's starting with stops that typically not represented in a window of time, it's not known beforehand, and it's possible to compute using this arbitrary stateful stream processing. What a mouthful. Okay, there are also joins available, and you can apply machine learning models. I mean, the ML libs available in Apache Spark can be trained on the batch mode and then applied in streaming mode using structured streaming. Now let me go quickly over Spark streaming because I still have two examples I would like to show you. And Spark streaming has been around for longer, as I mentioned at the beginning, and the model is slightly different. The model is, it came out of the idea that let's use, Spark is very good at handling batches of data. How can we do streaming? All right, let's do streaming by cutting the data into small pieces called microbatches and giving them to Spark. Once a Spark is done with it, we take the results and we give it to whoever is interested at the other side. Again, the same basic, or the same fundamental streaming model also applies. We have a source. We have something that processes the data coming from that source, and we have a sink at the other side where the data is produced too. A particularity here is that the streaming API for Spark streaming is based on the functional blocks available on Apache Spark. All the functions that we're going to see, sorry, let me just get through this really quickly. So every microbatch is represented by an RDD. That RDD of data can be then processed using the RDD functions. It's a functional programming API. And at the end, we can produce the data in some external system. And here are the functions that I was talking about. So we have a functional API available in Spark Streaming. If you're coming from Scala, this is really familiar. We have map, flat, and filter that applies on the elements of the stream. And then we have reducing functions that take a number of elements in the stream and produce a result. Onion joins to get two or more streams together in different forms, applying also a function to join them. Stateful processing, map with state, is a way of taking data in the stream and having a view of my state, my current state right now. Let's think about, again, these driving cars. What I'm going to do is I get an event of a displacement or a movement of a vehicle, and I have to see in my current state, do I know that a vehicle was moving already, or it just started, or I'm just updating, let's say, the path of the trajectory of that vehicle over time. That's stateful processing. It's available there. And then actions are used to produce the data to some other system. The most useful one is the for each RDD. The other print, it's just printed to the console. It's very helpful when you're getting started, but not, you will not use this into production or into something that is really getting serious. Save as text files. It will help you to save some text or some files on the file system, but you need to be very careful with it because it will create very small files over time that might fill up your storage really quickly. So take that with care. The best way to approach an output in Spark Streaming is using the for each RDD that gives you access, then again, to all the facilities that are available on Apache Spark. So you have access to all the libraries and also an external library. Let's say you have a custom database with a proprietary database driver. You can instantiate it here and write your data to the database. Okay, so I have the second part of the example written in Spark Streaming. And the reason for this, and I probably didn't touch it yet, is that Spark Streaming gives access to two levels in the computation of a Spark. It gives access to the local node, it's called the driver, and it gives access to the memory of the driver as well. So you can do some local bookkeeping, while you can do computing on the whole cluster. This duality makes it very powerful for really specialized applications where you need to keep track of things that are happening right now, and you need the power of computation that a cluster can provide you. I'm going to make that maybe more concrete with this example that I'm going to show you right now. I'm going to try to define a model for anomaly using the data coming from my sensor. So far, we have been just producing data, and the data that is coming in the secondary stream is already smoothed out. And I'm going to use that smooth out data or this moving average data to train a model. And it's a bit complex to get into the details of it, but what I want to give you is the core message here. If I'm going to use one of the most simplistic approaches or naive approaches to anomaly detection, and is computing the standard deviation and the median of the sample data, and then determining if some new sample is outside of some ranges from the standard deviation. The classical formula for standard deviation requires you to have to have access to all the data for that particular element. That's something that we don't have. We have data that's passing through the system. And then what we need is an algorithm that fits into that streaming model. I'm going to use M2. I'm using M2 here. It's one of the available streaming algorithms for computing the mean and the standard deviation. So this is, and this is the key of this example, and it might be a little bit hidden behind all the math here. But the key is that we have access to this RDD in this computation. This RDD gives us access to the cluster, so I am going to update my functions, or update my view on the data, of my current elements on the data, in the cluster, and then I'm going to add this to some model that is local. That means I have the model in my local memory. I can use it by means of the standard Scala, but I'm enriching that model, actually applying my learning technique using the whole cluster. Okay, so I have now a custom model. I programmed it myself, as you can see there, and I'm going to define a context. This is the way of reading from Kafka. It's a bit different from the Spark streaming, from structured streaming in the sense that it requires a little bit more ceremony. There we have to call a given provider, in this case Kafka utils, and give them a particular context called the streaming context. And in that way, we create a source for Spark streaming. In the same way as before, I'm going to provide some schema information and create a model. This model is local. And then again, this is very important. This model is in the memory of one element in the cluster, being the driver, and is not available in the rest of the cluster. And that is powerful because we are getting out of the stream. That's something that structured streaming cannot do. You cannot go outbound of a stream, whereas here in the Spark streaming, we have access to the two levels of computation, in the cluster and local as well. All right, so I'm going to first read my data. As you can see, the operations are a little bit more, let's say, programming-like. They have more verbosity. They also shows the age of the API. And I am going to train this on the data that is coming in. And I'm also going to do some scoring here, but I'm not going to use it right away. What I want to do is to, once I have created that, I would like to use it to score the data using another streaming system. Okay, so I'm just creating some widgets in my notebook to visualize the data. And then my computation for anomalies are defined. Nothing of this is doing anything. So I'm just declaring things. Every operation here is lazy, and it requires the starting of that stream to be able to materialize it. That's very different from structured streaming, where we saw that we could write a query and then immediately have the results. In the case of a Spark streaming, it's an all or nothing approach. We have a session. Inside that session, we declare all the operations we want to achieve in that stream, and at the end, we say start. Once we say start, everything starts working. Okay, so let's get to that point of a start, because we still have some other example to do. And there we go. So in 30 seconds, we will have some data here. And we have data already flowing in. So this is just samples of data that are coming through the system. And let's go very quick through a recap of what we just saw. While we are doing this recap, our model is learning. And every so many seconds, I'm writing that model to disk. And I'm hoping we can use it right now to try to find some anomalies in our data. Okay. First of all, we need a streaming context. Now, it's different from structured streaming, where the newest Spark session gives you access to batch and streaming at the same time. Here, we need a particular context that we need to create. The second parameter is one of the most important parameters in Spark streaming. It defines the micro batch size in terms of time. So every 10 seconds, I'm going to do something. And there was also, it's probably the most restricting element of the model, because you cannot get out of these 10 seconds. If you want to create a window, that window needs to be a multiple of those 10 seconds. You cannot do a window of 15 seconds or 45 seconds. You need to do 50 or 1 minute. And we need we have different providers for creating the sources. We use transformations to get access to the data in forms of RDDs and apply functions to that RDD. We have full access to the low-level API of Spark using these operations. But as they say, with great power, what comes next, you need to be very careful of what you are doing. So you have more power, but you also have more chances of doing something that is not going to work. It's a little bit more complex than with structured streaming, that things work probably out of the box. I created a custom machine learning model, a simplistic one that is learning my standard deviation over time. And we can do output using that for each RDD. The for each RDD gives you access to any API you have there. In this case, I'm using the API of the notebook itself to update the data that you see in the notebook. We can use this to do a very complex computing. I helped a consultancy company solve a very complex problem of ordering of events coming in and state handling using Spark streaming by combining local history, keeping history of certain past events with the stream that's coming in. So joining state data with the stream as it was coming in, but updating that data as well. We can do, as we saw, we can learn. In the machine learning context, there are not that many machine learning models that work fine in a streaming way. Spark streaming comes with a clustering implementation for streams, but next to that, you are much on your own. If you want to implement some, you need to get on and do it yourself. We can join data with data coming from databases or from files, and using that last but not least example or opportunity to show something more. Structured streaming comes with a new, came in the version 2.3 with a new engine, and it's a real-time engine. So it does not use that microservice, the micro-batch model, but it uses a continuous processing model. And we're going to use this continuous processing to see if we can catch any strange events in our system. And this is very similar to the first example we saw. So I'm just going to jump through it. I just want to see the demonstration. So we're doing the same. We're parsing the data. In this case, we're parsing the data coming from that machine learning model we created. It didn't have much time to learn that machine learning model. So probably we will have a lot of false positives. Okay, so what we just saw there is very similar to the first example, just defining my schema, reading from my schema, parsing the data. And now we're going to define here a mapping saying I'm going to do a scoring using that model that I trained on Spark streaming, having the data flowing in real time from Kafka. And we are used the classical threshold multiplied by the standard deviation plus or minus the mean to say, okay, this is something that is suspected to be outside of the normal range that I have observed up to now. And I will call this a candidate of anomaly. All right, so let's see if, do I still need to do something here? Yes, running through and start. All right, so we have a number of candidates, and now it's up to you to create an anomaly. Let's create an anomaly here. All right. Great, thank you very much. Look at this. So we have our sensor there shining, saying, oh, this is something really weird happening here. We have detected that this session was anomaly fun at some point. And with this, I'm going to stop this example and go to some conclusions. All right, so we have seen the whole flow. We started with the raw data. We first created a smooth outline using moving windows, moving average. We use that information to create a model in real time using Spark streaming, processing that stream of data. We provided oops, sorry, I think I ran out of time. So and we use that model to then score the data coming in. The conclusion of this presentation, that's the takeaway for today, this comparison between structured streaming and Spark streaming. Time in structured streaming is abstract. It's defined by the processing time by the event time embedded in the system or in the data. In the Spark streaming, we have a fixed microbatch. There's 10 seconds we saw there. They are fixed. You cannot change once that stream processing is started. At the execution level, we have different execution models for structured streaming. We have access to the fixed microbatch that we have in the past. We have a best effort microbatch. That's what I used in the first example to show how the data of the sensor was flowing. It's best effort microbatch. It's not the real-time engine, but it's doing as much work as possible, as fast as possible. And then we have this continuous stream processing that we just saw with the last example that gives us near real-time access to the data. On Spark streaming, we have that fixed microbatch model, so we have the set time that we use to process the data as it flows through the system. At the level of abstraction, we have the data frames data set API. You use one mental model to apply to batch processing and stream processing using data sets and data frames on structured streaming. On the other hand, on Apache Spark, we have the access to the RDD level programming. And if we have, let's say, the need or the requirement to access that level of facility or level of abstraction in Spark, it's possible with Spark streaming. I give there an extra star because we have access to the scheduler. We have this two-level scheduler on Spark streaming where we see data. We see the elements in the driver, but we also see the elements in the cluster, and we can play with this duality to implement advanced use cases. This is just some rule of thumb. Structured streaming gives you like 80% of the functions or features that you're required to create a new project, but depends very much on the project, of course. You first need to focus on your problem at hand or your requirements. And last but not least, pitch or the fast data platform, we include support for Spark as one of our stream processing engines on top of curated selection of components that are all pre-integrated and work together, warranted work together to help you implement streaming applications for your own business. All right, and with this, I would like to thank you for attending, and if you have any questions, I think we have like 2 minutes, 1 minute. One question then. Who has a question? All right.
So the model that you train, of course, it's a batch operation. So you train on a bunch of data that you accumulated in the past. But there are some machine learning models that you can train online. So it's training one sample at a time, so one data point at a time. They don't have the reputation to perform very well, but I don't know if you looked at them, if you have some experience with them, so that you could do both your training and the model training and update, and both the prediction, but as a full stream process instead of mixing batch and streaming.
Yeah, there are efforts in that direction. Databricks themselves, they have a project on doing stream analytics on structured streaming, but there are not many results out there. So I have done some research on that as well. There on Spark streaming, you only have clustering that is available, that is tuned for streaming. It has the mode of forgetting data as data evolves. There is a great talk by Ted Dunnan that is talking about statistical structures to help you learn in streaming, but they are not really machine learning models. It's like the step to get there. But I recommend to look up that talk that was in the Spark Summit last year. Yeah. But indeed, it's still a challenge, and it's very much a research challenge.
Thanks, and great talk.
Thank you. Wait, you have. All right, thanks a lot for attending.